Okay, today class we are going to be learning about proportions, and the TEKs that line up with this is 6.5a. The student is expected to represent mathematical and real-world problems involving ratios and rates using proportions. So, hopefully, by the end of this lesson, the student, you, will be able to solve problems using proportions. So to begin with, what is a proportion? Well, a proportion is a statement that two ratios or rates are equivalent or equal. Okay, so let's start off with a problem to figure out how to do these proportion things. So there are a couple important rules of proportions, and the first one is that after reading the problem, everything has to be lined up. So let's read the problem. Sheldon and Leonard are partners in a business. Sheldon makes $2 in profits for every $5 that Leonard makes. If Leonard makes $20 on the first item they sell, how much profit does Sheldon make? Okay, so like I said, the most important rule of proportions and the first rule is that our numbers have to line up. So, in order to create my proportion, I need to make sure I have a Sheldon line of numbers and a Leonard line of numbers. So I'm going to have my Sheldon line of numbers be on top. So there's Sheldon. And then on bottom, I will have Leonard. Alright, now I'm ready to start diving into the problem. So now I want to create my proportion. So let me reread parts of the problem. Sheldon makes $2 in profit for every $5 that Leonard makes. Well, they're talking about Sheldon, so I have a Sheldon number, and my Sheldon number has to go on top because I need everything to be lined up. So I'm going to put $2 on top. Then it says for every $5 that Leonard makes. Well, $5 is a Leonard number. So I am going to put my 5 on bottom. So now it says if Leonard makes $20 on the first item they sell, that's another Leonard number, so it goes on bottom. How much profit does Sheldon make? Well, I don't have another Sheldon number, but I have a blank, so I'm just going to put a box there for now. So now I need to solve this problem, and I need to know my next proportion rule, or my next proportion method to solve this. So one way to do this, and there's multiple ways to solve proportions, is to find a common denominator. And a common denominator are these bottom numbers here. And I want to make those two bottom numbers equal, or equivalent, because proportions are equivalent rates or ratios. So, in order to do that, I need to think, what can I multiply my 5 by in order to make that happen? Well, I know 5 times 4 is 20. So, I'm going to multiply the 5 times 4. So now 5 times 4 equals 20. So my bottoms, I have a common denominator. There's another rule of proportions, is that whatever I do to the bottom, I must do to the top. So if I multiply my 5 times 4, I have to multiply this 2 up here by 4 also. So now when I do that, I get an equivalent fraction over here of 8/20ths. And I'm just going to rewrite it down here. So this is what my proportion looks like now. So, proportions are equivalent, so they have to be equal. Well, if my 20 on bottom here is equal, then my tops have to be equal also. Therefore, my box equals 8. So, if Leonard makes $20 in profit on the first item they sell, Sheldon makes $8. So see, proportions are easy. You just have to make sure everything is lined up. So let's try another example. So here's my next example. The distance Ali runs is 36 minutes and is shown on the pedometer. At this rate, how far could he run in 60 minutes? Well, we don't have a pedometer, but I do know that the pedometer, and I'll draw a little pedometer right here, it said that the pedometer said 3 miles. So here's our pedometer over here. So how are we going to set this up? So I need, remember my first rule of proportions is I have to have a common, I have to have all of my numbers lined up correctly. So let's make my line. So I got a minute line. So I have all my minutes will line up. And then I have a distance line. So now I should be good to go. I should be able to set up my proportion, and we can solve this. It'll be fantastic. So let's read the problem again and pick out information. So the distance Allie runs is 36 minutes. Well, there is a minute number. So 36 minutes. And it's shown on the pedometer. So I look at my pedometer over here, and it says 3. Okay. And so then it says, at this rate, how far could he run in 60 minutes? So I have another 60-minute number, or I have another minute number, and I don't know my distance, so I'm just going to put a box. So first step, as before, I looked for a common denominator. So I'm looking. And we're running into a problem. Oh no, I can't do a common denominator because we are missing a number. I have a box here in my common denominator. What can I do? And then, so if I can't get a common denominator, another way I could do it is get a common numerator, because if I multiply whatever I multiply the bottom by, I multiply by the top, so it would be common. But there's nothing that 36, multiplies by to get me 60. So now what do? Well, there's another method. There's another way to do this, and it's to find a unit rate. And a unit rate would be, in this case, it would be how many minutes it takes him to run 1 mile. So how many minutes it takes for 1 mile. And that's it. We just need to find that unit rate. And then that unit rate we'll be able to use in order to solve our proportion. So the way I'm going to do this is I want to get a 1 here on the bottom. So how can I do that? Well, 3 divided by 3 equals 1. So I'm going to divide by 3. And whatever I do to the top, I must do to the bottom, or vice versa. Whatever I do to the bottom, I must do to the top. So that will give me 12 minutes for 1 mile, and that is my unit rate. Now is this equivalent to 36 over 3? Well, yes, of course it is, because I can multiply that 12 over 1 by 3 and get my 36 over 3 again. So, because they are equivalent, I can substitute this unit rate into my proportion for 36 over 3. So now I'm going to have a new unit rate I'll have a new proportion that will look something like this. 12 over 1 equals 60 over my unknown box. So now what do? Well, now I can try to find a common denominator or numerator. I fall back onto my old rules. So I can't find a common denominator because I still have this pesky box there, but I can find a common numerator because I know 12 times 5 will give me 60. And whatever I do to the top, I must do to the bottom. So I will multiply that 1 by 5 also. So that will give me 60 over 5 equals 60 over my unknown box. And one thing about proportions, as we know, is that they are equivalent. So if my 60s are equal, that means that my box equals 5. So that means that in 60 minutes, he could run 5 miles. And that is our answer, 5 miles. See, proportions are easy.